actually is the general equations for calculate normal stress and shear stress. So in principle, general case for normal stress can caused by the axial load and true bending moment. But if the point is only one of the axes, then only one bending moment can generate the normal stress. Another bending moment will simply contribute zero because it will fall on the new axis. And for the shear stress, in principle, you have two shear forces can cause shear stress and also the torsion moment. But again, if the point is on one of the axes, then one of the shear force can't contribute the shear stress because it's actually on the edge. So this is relevant idea. It depends whether it's on the neutral axis or on the edge. It depends on the direction of the force and load. So general case, if I ask you to find out, for example, A, B, C, D, which force on the axis is established X, Y, Z, each of them, the final equation is like this. Right? For normal stress, there are two components. One is the axial load, one is the bending moment. The same thing for the shear stress. So the first thing, if you check, okay, the point is falling on the one axis. Eventually, I have an equation like this, and another one must be zero because it's loaded. If you look at that in certain direction for shear stress, for example, for B, the shear stress in Y direction will be cause zero shear force will cause zero shear stress. So just compare the example we gave yesterday. So in principle, you have 6 independent loads, the internal load, and they can potentially cause 3 normal stresses and 3 shear stresses. But eventually, if you look at the equation, it's like you have normal stresses, one is axial load, one is bending moment, another bending moment will cause zero normal stress. And the shear stress, the first part is the shear force, and the second part is torsion moment. So this is for the points on the axis. Those two actually you can consider general equations to calculate the normal and shear stresses for the combined load situation. But firstly, you make sure the point does fall on one of the axes to establish the point. Right? In that case, actually this is the common case. You will have these equations for calculate the normal stresses, normal stress and shear stress. And I mentioned in this case, the point is on the surface of B. So this is a typical case for the stresses in the falling always into one leg. So we call it high stress. And in this case, we have generally 3 independent values to describe the status of stresses. All right. So this is another important component for this subject, plane stress. And if you consider the stress in your direction, just like the force,